Okay, this question represent of closed system. Usually piston and cylinder will represent closed system, and closed system will involve no mass transfer. So the mass is just inside this system without going out from this cylinder. So in this question, the initial gas temperature is 25 degree, and then the cylinder is placed in boiling water with the piston held in a fixed position. Heat in the amount of 2 kilocalorie. So this means Q. Okay, Q is represent heat. So the heat that have been supplied into the system is 2 kilocalorie. So after that, which equilibrates at 100 degree. So this can represent stage 1, okay, where the temperature from 25 to 100 degree. So one energy balance process have occurred at this first stage, and then the piston is then released and the gas does 100 joule of work. So this means W is equal to 100 joule in moving the piston to its new equilibrium position. So this part is stage 2. Okay, so there is 2 stage where the energy balance occur. So the question asks you to write the energy balance for each of the 2 stages of this process and solve the unknown. Okay, so at the first stage, we know the initial state is 25 degree and increase to 100 degree. As I mentioned earlier, the heat that have been supplied to increase the temperature from 25 to 100 is 2 kilocalorie. So this is the energy balance equation. So we know we want to find the internal energy. Okay, and we have to consider kinetic energy is equal to 0 as the system is stationary, means the cylinder is stationary, and then at this stage no vertical displacement, means the piston is at the same position, so no potential energy, and then is equal to Q minus W. So there is no work occur at this stage. So that's why delta U is equal to Q. So we know Q is 2 kilocalorie. So finally we can determine the internal energy by multiply 2 kilocalorie. Not multiply, but it's equal to 2 kilocalorie. This part is just for the unit conversion. Okay, this part is for unit conversion for you to get or obtain the unit of joule. So at the first stage, the internal energy is 8,370 joule. This is for the first stage of energy balance. The second stage, again, we know this is the energy balance equation. So we have to identify first. So the delta U is equal to 0 because usually delta U is depending on the temperature. As we know, at the second stage, the temperature is maintained at 100 degree C. So we can consider delta U as 0. And how about kinetic energy? The system is also stationary, it's not moving. So we can consider it as 0. The potential energy we can assume as negligible based on the question. And then we know that here we'll make it into 0. Then equal to Q minus W. And then we know that the work that have been given in the question is 100 joule. So the heat transferred in this second stage is 100 joule.